everyone, welcome to Study Jam. In this video, we will be looking at Cambridge A-Level Pure Mathematics 1, question paper 12 of May-June 2022. If you liked this video and found it helpful, please leave a thumbs up and share it with your peers. If you would like to receive updates on future videos, don't forget to hit the subscribe button as well as the notification bell. Question 1. The coefficient of x power 4 in the expansion of 3 plus x bracket power 5 is equal to the coefficient of x squared in the expansion of 2x plus a over x power 6. Find the value of the positive constant a. To find any term in a binomial expansion, we can use the formula n choose r times a power n minus r times b power r. So for this equation, our a is 3 and our b is x. So we want to find the coefficient of x power 4 in this equation or in this expression. So x power 4. So our r is 4 and our n is 5. So we have 5 choose 4 times our a, which is 3, power n minus r, which is 5 minus 4. So we get 5 times 3 times x power 4. This gives us 15 x power 4. So this is our coefficient for x power 4. So now we want to find the coefficient of x squared in the expansion of 2x plus a over x power 6. Our 2x is our a, and our a over x is our b. To find x squared in this expansion, we need to find the power of x from our 2x that will multiply with 1 over x from a over x to give x squared. So x power 4 times 1 over x squared will give us x squared. They'll cancel off each other to give x squared. So 2x will be to the power 4 and a over x will be to the power 2. So according to the formula, it's n choose r times a n minus r times b power r. Our r here, in this case, is 2, and our n is 6. So this will be 6 choose 2 times 2x power 4 times a over x power 2. So this gives us 15 times 16x power 4 times a squared over x squared. So this will be 240 a squared x squared. So now we have our coefficient for x squared. So it says that the coefficient of x power 4 in this expression is the same as the coefficient of x squared in this expression. So we equate 15 from the previous expression to 240 a squared. So a squared will equal to 15 over 240. So a will be the positive or negative square root of 1 over 16. But since it's already mentioned in the question that a is a positive constant, then a will only be the positive square root of 1 over 16, which is 1 over 4. So that will be your answer for question 1. Question 2. The second and third terms of a geometric progression are 10 and 8 respectively. Find the sum to infinity. So sum to infinity is a over 1 minus r. So first we need to find our a and our r. The geometric progression is a, 10, and 8. So first we can find our r by dividing our third term with our second term. So r equals to 8 over 10, which gives us 0.8. Now we can find for our a. So we'll use the formula for a geometric progression, which is un equals to a times r power n minus 1. So we'll use our second term. Our second term is 10, so this will be a times r, which is 0.8, power n minus 1. So n minus 1 is 2 minus 1. So a will be 10 divided by 0.8. So this gives us 12.5. So our sum to infinity will be 12.5 1 over 1 minus 0.8, and we'll get 62.5. This is our sum to infinity. Question 3. The equation of a curve is such that dy dx is 3, look at 4x minus 7 power half, minus 4x power negative half. It's given that the curve passes through the point 4, 5 over 2. Find the equation of the curve. To find the equation, we can integrate our dy dx. So y will be our integration of 3, bracket 4x minus 7 power half minus 4x power negative half dx. So integrating this term, we get 3, 4x minus 7, and 1 over 2 plus 1 will be 3 over 2. Then dividing by the power, we get 2 over 3. Then divide by the differentiation inside the bracket. So we get 1 over 4. And then minus, so integrating this term, we'll get 4x half 1 over 2 plus 1 is 1 over 2. Then divide by the power, we get 1 over 2. 1 divided by 1 over 2, we'll get 2. And then a plus c, as we don't have any limits. So y will be 1 over 2 4x minus 7 power 3 over 2 minus 8x power half plus c. So to find our c, we can substitute in our given coordinates. So our y is 5 over 2, our x is 4. 4 minus 7, 3 over 2 minus 8, 4 half plus c. So simplifying each term, we get 27 over 2. And this term we get 16 plus c. So rearranging, c is 5. So our equation is y equals to half 4x minus 7 power 3 over 2 minus 8x power 1 over 2 plus 5. That is your equation of the curve. Question 4. The first, second, and third terms of an arithmetic progression are k, 6k, and k plus 6 respectively. Part A. Find the value of the constant k. So we can find the value of constant k by this method. So the difference of the arithmetic progression will be the second term minus the first term. The difference will also be the third term minus the second term. So if we minus our second term from our first term, we get 6k minus k, 5k. This will be our first equation. And then our difference is also the third term minus the second term. So k plus 6 minus 6k. This will give you 6 minus 5k, the second term. So we can equate our first equation to our second equation. So 5k equals to 6 minus 5k. 5k plus 5k equals to 6. So 10k equals to 6. So our k will be 6 divided by 10 is 0.6. So that will be your answer for part A. Part B. Find the sum of the first 30 terms of the progression. So the sum of any of the first n terms of a progression will be n over 2 bracket 2a plus n minus 1 times the difference. So we need to have our a and our difference. So we had our progression, which is k, 6k, and 6 plus k. And we found our k, which was 0.6. So our progression will be 0.6, 3.6, and 6.6. So our difference will be 3, because we're at 3 each time. So we want the sum of first 30 terms. So our S, sum of first 30 terms, will be 30 over 2 times 2. A is 0.6. 2 times 0.6 plus 30 minus 1 times 3. So 15 times 1.2 plus 87. And you'll get 1323. So that is your answer for part B. Question 5. The equation of a curve is y equals to 4x squared minus kx plus 1 over 2k squared. And the equation of a line is y equals to x minus a, where k and a are constants. Part A. Given that the curve and the line intersect at the points with the x coordinates 0 and 3 over 4, find the values of k and a. So since the line and curve intersect, we can equate these two equations. So 4x squared minus kx plus 1 over 2k squared equals to x minus a. So we can form two equations by substituting these x coordinates. So the first one is when x equals to 0. Then we'll get 4, 0 minus k 0 plus 1 over 2 k squared equals to 0 minus a. So negative a will equal to half k squared, and our a will equal to negative half k squared. So this is our first equation. So substituting in our second x coordinate, we'll get 4 3 over 4 squared minus k 3 over 4 plus half k squared equals to 3 over 4 minus a. So simplifying, we get 9 over 4 minus 3 over 4k plus half k squared equals to 3 over 4 minus a. And our negative a earlier was half k squared, so plus half k squared. I'm going to move all the k's to one side of the equation, so half k squared minus half k squared plus 3 over 4k. Then I'll move 3 over 4 to the other side of the equation, so I'll get 9 over 4 minus 3 over 4. Half k squared minus half k squared is 0, so I'm left with 3 over 4k equals to 6 over 4. So k will equal to 6 over 4 divided by 3 over 4, or you can write it as times 4 over 3. It's the same as divide by 3 over 4, so you'll get k equals to 2. So now for our a, it was negative half k squared, so negative 1 over 2 squared. So 4 times negative half is negative 2. So our values of k is 2 and our a is negative 2. That's your answer for part A. Part B. Given instead that a is negative 7 over 2, find the values of k for which the line is a tangent to the curve. So earlier our straight line equation was y equals to x minus a. And because now our a is negative 7 over 2, the equation is now x plus 7 over 2. So we can equate this equation again to the curve. So 4x squared minus kx plus 1 over 2 k squared equals to x plus 7 over 2. And we'll rearrange this equation to move it to the other side. 4x squared minus kx minus x plus 1 over 2 k squared minus 7 over 2 equals to 0. So since the line is a tangent to the curve, it means it intersects the curve only at one point. So we can use the equation b squared minus 4ac equals to 0. So our a value will be 4. Our b value will be negative kx minus x. So combining these two, we'll get negative k plus 1x. So this will be our b value. And our c value is half k squared minus 7 over 2. So substituting b squared, k plus 1 squared. We can also put negative k bracket k plus 1 bracket square, but it will turn out the same value if we expand anyway. So I'll just put k plus 1 square. Then k plus 1 square minus 4. A is 4. C is half k squared minus 7 over 2 equals to 0. So then we'll get k squared plus 2k plus 1 minus 8k squared plus 56 equals to 0. So simplifying, we get negative 7k squared plus 2k plus 57 equals to 0. So I'll times this with a negative 1. I'll get 7k squared minus 2k minus 57 equals to 0. Factorizing gives me k minus 3 and 7k plus 19. So my k values are 3 and negative 19 over 7. Question 6. The diagram shows the curve with equation y equals to 5x power 1 over 2 and the line with equation y equals to 2x plus 2. Find the exact area of the shaded region which is bounded by the line and the curve. So to do that, we can first find the area under the curve and then minus it from the area of this trapezium. So to find the area under the curve, we first need to find our limits or the intersection of the curve and the line. So we can do 2x plus 2 equals to 5x power half. And then you'll have 2x minus 5x power half plus 2. You can treat this like a normal quadratic equation and use your calculator to factorize it, and you'll get 2x power half minus 1 and x power half minus 2. So you'll get x power half equals to 1 over 2 and x power half is also equal to 2. So our x is 1 over 2 squared, which should give us 1 over 4, and 2 squared, which gives us 4. So these are our limits. So to find the area under the curve, we need to integrate the curve equation. So our area will be the integration of 5x power 1 over 2 with limits 4 to 1 over 4. Integrating 5x power 1 over 2 will get 5x power 3 over 2, and then dividing by the power will get 2 over 3. 4 to 1 over 4. So 4 power 3 over 2 times 2 over 3 minus 5, 1 over 4 power 3 over 2 times 2 over 3. And you'll get 105 over 4. So this is your area under the curve. So now you'll need the area of trapezium. So for area of trapezium, you'll have a plus b over 2 times your height. So your height will be from 1 over 4 to 4, and your a and b will be the y-coordinates of your respective points. So you'll need to find the y-coordinates. So when x is 1/4, your y is 2 1/4 plus 2, you get 5/2. And when your x is 4, your y will be 2 times 4 plus 2, which is 10. So insert that into your equation of area of trapezium. So it will be 5/2 plus 10 dividing by 2 times height, which is 4 minus 1/4. And you'll get 375/16. So your shaded area or area of shaded region will be 105/4, which is our area under the curve, minus the area of trapezium, which is 375/16. You'll get 45/16. So this is your area of shaded region. Question 7. The diagram shows a sector OBAC of a circle with center O and radius 10 centimeters. The point P lies on OC and BP is perpendicular to OC. Angle OAC is 1/6 pi, and the length of the arc AB is 2 centimeters. Find the angle BOC. So our angle BOC will be angle AOC plus angle BOA. That will be our angle BOC. So we already have our angle AOC, so we need to find the angle for BOA. We can use the formula arc length equals to r theta. So our arc length is 2 centimeters. Our radius is 10 centimeters. So times theta. So our theta for BAO will be 2 divided by 10, which is 0.2. So our angle BOC will be 0.2 plus 1/6 pi. You can also write it to 3 significant figures, which will be 0.724 radians. Both are correct. Part B. Hence find the area of the shaded region BPC, giving your answer correct to 3 significant figures. So we want area BPC, which I already sketched out and highlighted here. So first we can find the area of the sector and then minus it with the area of the triangle. So the area of the sector will be 1/2 r squared theta. So our radius is 10. Our theta will be BOC, so it's 1/6 pi plus 0.2. We'll get 36.180. And then for our area of triangle, we'll need to find first length OP and length BP. So we can use the trigonometry rules. So for OP, we can use cos theta equals to OP over OB, which is the adjacent over the hypotenuse. So cos pi over 6 plus 0.2 equals to OP over 10. So OP will be cos pi over 6 plus 0.2 times 10. which gives us 7.494. Then we can find our BP by using the sine rule. So sine pi over 6 plus 0.2 equals to BP over 10. So BP is 6.6209. So our area of triangle will be 1 over 2 times 7.494 times 6.6209. This gives us 24.808. So we have our area of sector and area of triangle. So our area for BPC will be 36.180 minus 24.808. This will be 11.4 centimeters squared. Give your answer to 3 significant figures as per what the question asks. So this is your answer for part B. Question 8. The equation of a circle is x squared plus y squared plus ax plus by minus 12 equals to 0. The points A 1, 1 and B 2, negative 6 lie on the circle. Part A. Find the values of A and B and hence find the coordinates of the center of the circle. So we can find A and B by constructing two equations, substituting these points onto the equation of the circle. So first substitute point A into circle, so we'll get 1 square plus 1 square plus A bracket 1 plus B bracket 1 minus 12 equals to 0. So 1 plus 1 plus A plus B minus 12 equals to 0. We'll get A plus B minus 10 equals to 0. So that is our first equation. So we can substitute points B to get our second equation. So 2 square plus negative 6 square plus 2A minus 6B minus 12 equals to 0. So 4 plus 36 plus 2A minus 6B minus 12 equals to 0. 2A minus 6B plus 28 equals to 0. So we can rearrange our first equation to make A the subject. So A will equal to 10 minus B. And then we can substitute this equation into our second equation. This is our second equation. So 2, 10 minus B minus 6B plus 28 equals to 0. 20 minus 2B minus 6B plus 28 equals to 0. So we'll get negative 8B plus 48 equals to 0. 8B equals to 48. So our B will equal to 6. So our A is 10 minus B. So it will be 10 minus 6. And we'll get 4. So to get the center of the circle, it will be our negative A over 2. And our y coordinate for the center of the circle will be our negative B over 2. So we have our A, which is 4. So it'll be negative 4 over 2. and our y is 6, so it'll be negative 6 over 2. So our coordinates of the center will be negative 2, negative 3. So our A is 4, our B is 6, and our center will be negative 2, negative 3. So that's your answer for part A. Part B. Find the equation of the tangent to the circle at the point A, giving your answer in the form px plus qy equals to k, where p, q, and k are integers. So to find the equation of any line, we first need to find, one, the gradient, and second, we need to know the point that lies on the line. So since this is the equation of the tangent on A, our point on the line will be the point of A, which is 1, 1. So now we need to know the gradient of the tangent. To know the gradient of the tangent, we can first do so by finding the gradient between the center, which we'll call C, and A. Because by finding the gradient of the center and A, we can use the perpendicular formula to find the gradient of the tangent at A. Okay, first, we'll find the gradient between CA. So gradient CA, which will be the y of C minus the y of A, so negative 3 minus 1, over the x of C minus the x of A. So negative 2 minus 1. We'll get negative 4 over negative 3. This is 4 over 3. So the formula of two lines that are perpendicular to each other is m1 times m2 equals to negative 1. So 4 over 3 times m2 equals to negative 1. So m2 is negative 1 over 4 over 3. So m2, or also the gradient of our tangent, will be negative 3 over 4. So now that you have your gradient, which is negative 3 over 4, and you know the point that lies on the line, which is A, 1, 1, you can substitute it back into the equation for any line, which is y minus y1 equals to m x minus x1, where your y1 and x1 are the coordinates of the point that lie on the line. So substituting, we get y minus 1 equals to negative 3 over 4 times x minus 1. So moving this 4 here, we get 4 times y minus 1 equals to negative 3x minus 1. So 4y minus 4 equals to negative 3x plus 3. So earlier in the question, they wanted it in the form of px plus qy equals to k. So rearranging that, we get 4y, move negative 3 to the other side, we get plus 3x. And then moving 4 to the opposite side, we get 3 plus 4. So our equation of tangent will be 3x plus 4y equals to 7. So that will be your equation of tangent for part B. Question 9. The equation of a curve is y equals to 3x plus 1 minus 4 times 3x plus 1 power half, for x is more than negative 1 over 3. Part A. Find dy dx and d square y dx squared. So to find dy dx, we just differentiate the equation. So dy dx will be differentiating through x, we get 3. Differentiating 1, we get 0. So 3 plus differentiating -4 times 3x plus 1 power half, we'll get -4 times 1 over 2, which is the power, and then times the differentiation inside the bracket, which is 3, times the expression in the bracket, to the power 3x plus 1 to the power 1 over 2 minus 1 will be -1 over 2. So our dy dx is 3 minus 6 times 3x plus 1 power -1 over 2. And then our d squared y dx will be the differentiation of dy dx. So we get differentiating 3, we get 0. Then differentiating this term, we'll get -6 times -1 over 2 times 3 times 3x plus 1, then -1 over 2 minus 1 will get -3 over 2. So we get 9, 3x plus 1 power -3 over 2. So that will be your dy dx and d square y dx squared. Part B, find the coordinates of the stationary point of the curve and determine its nature. We use dy dx to find the coordinates of the stationary point, and we use d square y dx squared to determine its nature. So at the stationary point, dy dx equals to 0. So 3 minus 6 times 3x plus 1 power -1 over 2 will equal to 0. This expression can be rewritten as 3 minus 6 over 3x plus 1 power 1 over 2 equals to 0. So moving this term here, so we get 3 equals to 6 over 3x plus 1 power half. So 3, moving this part here, we get 3 times 3x plus 1 power half equals to 6. And then 3x plus 1 power half will equal to 6 over 3, which gives us 2. So then our 3x plus 1 equals to 2. Moving the power half to the opposite side, we get 2 squared. Then 3x equals to 4 minus 1. X equals to 3 over 3, which is 1. So this is our x coordinate for the stationary point. So earlier the equation of the curve was y equals to 3x plus 1 minus 4 times 3x plus 1 power half. So our y coordinate will be 3 times 1 plus 1 minus 4 times 3 times 1 plus 1 power half. So this gives us -4. So our stationary point is at 1, -4. To determine its nature, we substitute back our x coordinate into our d squared y dx squared. Earlier our d squared y dx squared was 9, 3x plus 1 power -3 over 2. So 9, 3 times 1 plus 1 power -3 over 2, we get 9 over 8. So our d squared y dx squared is more than 0. So that means our point is a minimum point. So our stationary point will be a minimum. That is your answer for part B. Question 10. Functions f and g are defined as follows. F of x equals to 2x plus 1 over 2x minus 1 for x does not equal to 1 over 2. And g of x equals to x squared plus 4 for all real values of x. Part A. The diagram shows part of the graph of y equals to f of x. State the domain of the inverse of f. So the domain of the inverse is actually equal to also the range of f of x. So we can use the graph to find the range of f of x. So referring to the graph right here, our range of f of x is more than 1 and also less than 1. So the domain of the inverse is more than 1 and less than 1. So that is your answer for part A. Part B. Find an expression for the inverse of f of x. So we can do this by let y equals to the inverse of f of x. So fy will equal to 2y plus 1 over 2y minus 1. So fy will become x. So x equals to 2y plus 1 over 2y minus 1. So you want to make x the subject. So moving this part to the other side, x times 2y minus 1 equals to 2y plus 1. So 2xy minus x equals to 2y plus 1. So we're going to rearrange this to 2xy minus 2y equals to x plus 1. Then factor out y. So it will be y 2x minus 2 equals to x plus 1. So y will be x plus 1 over 2x minus 2. So the inverse of f of x is x plus 1 over 2x minus 2. So that is your answer for part B. Part C, find GF inverse 3. So the first step we can do is find inverse f of 3. So inverse f of 3 will be 3 plus 1 over 2 times 3 minus 2. So this gives us 1. So GF inverse of 3 is also the same as G of 1. So this will be 1 squared plus 4, which gives us 5. So that is your answer for part C. Part D. Explain why inverse G of x cannot be found. So our G of x was x squared plus 4 for all real values of x. So if we sketch out the graph, it will look roughly like this. And since it's for all real values of x, g of x is a many to one function. An inverse can only be found if the function is a one-to-one function. So g of x is a many-to-one function and not a one-to-one function. Hence why inverse g of x cannot be found. So that will be your explanation for part D. Part E. Show that 1 plus 2 over 2x minus 1 can be expressed as 2x plus 1 over 2x minus 1. Hence, find the area of the triangle enclosed by the tangent to the curve y equals to f of x at the point where x equals to 1 and the x and y axis. Okay, so let's dissect this question one by one. So first, show that 1 plus 2 over 2x minus 1 can be expressed as 2x plus 1 over 2x minus 1. So show. So 1 plus 2 over 2x minus 1 1 can also be written as 2x minus 1 over 2x minus 1. So combine the numerators. 2x minus 1 plus 2 over 2x minus 1 will be 2x plus 1 over 2x minus 1. So we've already shown this part. So if you recall earlier, this expression or equation was f of x. The question wants us to find the area enclosed by the tangent. So if you sketch it out, it looks something like this. So the tangent to the curve at x equals to 1 will give us a triangle. So what we need to do is find the equation of the tangent so that we know the y-intercept and the x-intercept. Because the y-intercept will be our height and the x-intercept will be our base. So to find the equation of the tangent, we need to find the gradient and the point that lies on the line. So to find the gradient, we need to differentiate f of x. So f of x can be differentiated easier using this expression. So f of x will be 1 plus 2 over 2x minus 1. So we can rewrite this as 1 plus 2 times 2x minus 1 power negative 1. So it will be easier for differentiation. So the differentiation will be f prime x. So differentiating 1 gives us 0, and differentiating 2 times 2x minus 1 power negative 1 will be 2 times negative 1 times 2 times 2x minus 1 power negative 1 minus 1, which is negative 2. And we'll get negative 4 2x minus 1 power negative 2. So the gradient at x equals to 1 will be negative 4 times 2 times 1 minus 1 power negative 2. This gives us negative 4. So that is our gradient for the tangent. Now we can find the point that lies on the line. So to do that, we substitute 1 into f of x. So f1 will be 1 plus 2 over 2 times 1 minus 1. So this gives us 3. So the coordinates of the line, or the coordinates of the point on the line, are 1, 3, and our gradient is -4. So substituting these values into the equation of a straight line, so y minus 3 equals to -4 times x minus 1. Y equals to -4x plus 4. Then moving 3 to the other side, we get plus 3. So the equation of our tangent is -4x plus 7. So our y-intercept is 7. Our x-intercept will be when y is 0, so 0 equals to -4x plus 7. X will be -7 over -4, which is 7 over 4. So the area of the triangle will be our y-intercept times our x-intercept times 1 over 2. So our area is 7 times 7 over 4 times 1 over 2. This gives us 49 over 8. So that is your answer for part E. Question 11. Function f is given by f of x equals to 4 cos power 4x plus cos square x minus k, for x is more than or equal to 0 and less than or equal to 2 pi, where k is a constant. Part A. Given that k equals to 3, find the exact solutions of the equation f of x equals to 0. So given that k is 3, we'll just substitute it back into the equation. So f of x is equal to 4 cos power 4x plus cos square x minus 3. So 4 cos power 4x plus cos square x minus 3 equals to 0. So we can factorize out this equation. You can use your calculator for this. So factorizing out the equation, we'll get 4 cos square x minus 3 and cos square x plus 1 equals to 0. So you have cos square x will equal to 3 over 4 and cos square x will equal to -1. This right here is invalid because a square number cannot be negative. So your cos square x is only 3 over 4. So your cos x is plus minus square root of 3 over 4. So that means your cos x is positive 3 over 4, positive square root 3 over 4, and negative square root 3 over 4. So sketching out the quadrants, formula will be add sugar to coffee. So your positive angles will be in the first and last quadrants, and your negative will be in the second and third quadrant. Since your range is from 0 to 2 pi, that means it covers all angles. So for your first positive angles, it will be x will be arc cosine positive square root of 3 over 4. So you'll get 1 over 6 pi. So this right here is 1 over 6 pi, and this is negative 1 over 6 pi, which is also 11 over 6 pi. So your angles in the positive quadrants are 1 over 6 pi and 11 over 6 pi. And your angles in the negative quadrants are cosine negative square root 3 over 4. So this will be pi minus 1 over 6 pi and pi plus 1 over 6 pi. So your angles in the negative quadrants are 5 over 6 pi and 7 over 6 pi. So all your values of x will be 1 over 6 pi, 5 over 6 pi, 7 over 6 pi, and 11 over 6 pi. So that's your answer for part A. Part B. Use the quadratic formula to show that when k is more than 5, the equation f of x equals to 0 has no solutions. So earlier our f of x was 4 cosine power 4 x plus cos square x minus k. So this equation equals to 0. So we're going to use the quadratic formula to find the solutions of this equation. So the quadratic formula will be x equals to negative b plus minus square root of b squared minus 4ac over 2a. In this case, our x is cos square x, our b is 1, our c is negative k, and our a is 4. So substituting back these values, cos square x equals to negative 1 plus minus square root of 1 square minus 4 times 4 negative k over 2a, which is 2 times 4. So our cos square x will be negative 1 plus minus square root of 1 plus 16k over 8. So cos square x has both positive and negative solution. It's negative 1. It's either negative 1 plus 16k over 8 or negative 1 minus square root of 1 plus 16k over 8. This solution is invalid because a square number cannot be negative. So we're only left with this solution. So earlier in the question, it says when k is more than 5, the equation has no solutions. So we can try to do this by side comparison. So k is more than 5. 16k will be more than 80, then 1 plus 16k will be more than 80 plus 1. Then square root of 1 plus 16k will be more than square root of 81, which is 9. And then we have a negative 1, so negative 1 plus square root of 1 plus 16k is more than 9 minus 1. And then we divide by 8. So negative 1 plus the square root of 1 plus 16k over 8 is more than 9 minus 1 is 8. Divide by 8. So this whole expression here is cos square x. So cos square x is more than 1. So if you remember the original cosine graph, the range of cosine is only between negative 1 and 1. So cos square x is less than 1. So this particular expression has no solutions. So that will be your working for part B. Thank you so much for watching this video. If you found it helpful, please share it with other people so that they can benefit from it as well. If there's any feedback you would like to give, or if there's any specific paper you would like me to solve, feel free to leave a comment in the comment box below. Again, thank you so much and see you in the next video.